Okay, so here's the back part of the examples 3 SHRATEY worksheet. In this problem, the numerator is already in factored form, and so we don't have to do that anymore. It can't simplify any further, meaning there are no common factors that will cancel on the top and bottom. So there will be no holes created. So can't simplify, no holes, so we go straight to R. We set each of the factors individually equal to 0 and solve them. This will give us our roots. So on this first one, I subtract 1, then divide by 3. And on this one, I just subtract 2. I'm going to write those as ordered pairs because they are points. And then I will graph those. So negative 1/3, 0, and then negative 2, 0. And my vertical asymptote, set the denominator equal to 0 and solve, gives me x equals negative 1. And I'll go ahead and graph that. T is for tangent over together. We're looking for factors that are squared, and there are none. E is for end behavior. Now, for end behavior, we always set up the ratio of the leading terms. In factored form, I don't know what my leading term is. That comes from standard form. So I can imagine for a minute that I FOILed out those two binomials. So multiplying the first terms together gives me my leading term. So the ratio of leading terms is 3x squared over x, and that is top heavy, so I need to find my oblique asymptote. Now, in a different situation where it's balanced or bottom heavy, I don't need to finish foiling this out. All I need is my first term for that information. Because oblique asymptotes require me to do the polynomial division of the numerator divided by the denominator, in these situations, I do need to continue the FOIL process and get the entire expression. So the first terms are 3x squared. Outside is 6x. Inside is 1x, so that is 7x. And then the last terms are 1 times 2, which is 2. All right, so now I'm going to use that to set up my synthetic division. I'm using the 0 of the denominator, which is negative 1. My coefficients are 3, 7, and 2. So I'm going to bring the 3 down. 3 times negative 1 is negative 3. 7 minus 3 is 4. And I don't care about the rest, just these first two values. Add your x back in, so my slant or oblique asymptote is y equals 3x plus 4. And that makes my y-intercept 0, 4, and my x-intercept plugging 0 in for y. So imagine that's a 0. You're going to subtract 4, divide by 3. That is negative 4/3, or negative 1 1/3, or 1.3, or whatever. There's options. And those are going to be open circles because those are points on the asymptote. So 0, 4, and then negative 1.30. So squeeze that in there. All right. Now my y-intercept, I put 0 in everywhere I see an x. You can use the standard form or the factored form. I'm going to do standard form. It's just faster, I think. So 0 plus 0 plus 2 over 0 plus 1, which is 2. So my y-intercept is 0, 2. All right, now this one's a little bit funky. So I have these 2 points here, and I have my slant asymptote and my vertical. So I know that my curve is going to pass through these points and approach both of the asymptotes. So it's going to be very stretched out. Like that. And then the mirrored part is going to be between these two. And I happen to already have a root right there, an x-intercept. So I'm just going to draw this through here. And there you go. And for this last one, now we can factor the numerator this time. So what multiplies to 9 and adds to -6, and that's -3, -3. So my factored form is x minus 3 times x minus 3 over x plus 2. You also could write this as x minus 3 squared. There are no common factors top and bottom, so there are going to be no holes. Now to find my root, I set these factors equal to 0 and solve them. They're the same, so I just need to do that process one time. So x equals 3, so I have a root at 3, 0. And then a for my vertical asymptote, set the denominator equal to 0 and solve x equals -2. Tangent over together, I do have a squared factor now in my numerator. So that's going to be yes, I have no squared factors in the denominator. And what that yes means for me is that the graph is tangent at that root at 3, 0. And I'm not going to do anything with that information just yet, but when I'm ready to graph, I know that tangent means the graph is going to bounce off this point. It's not going to cross through the point. Okay, so that's what tangent means. All right, end behavior, my ratio is x over x. Definitely top heavy, so I have to do my synthetic division. The 0 of my denominator is -2. The coefficients of my numerator are 1, -6, and 9. So I bring down the first term, multiply these two things, -2, add vertically -8, and I don't care about the rest of it. So my oblique asymptote is y equals x minus 8. And my two intercepts are when x is 0, y is -8, and when y is 0, x is +8. So I'll draw those with open circles. Oh wait, sorry. That's backwards. When y is 0, x is 8. Now my y-intercept, put 0 for all the x's. I'm using the factored form, or sorry, I'm using standard form, the original equation. So that is 9 over 2, so 0, 9 halves. Or you can think of it as 0 and then 4.5. And that is going to be a solid point because it's on the graph. All right, so our goal now is to get our curve to go through the y-intercept, tangent at the root, and then approach that oblique asymptote over there. So wish me luck. I'm not going to be very good at this. It's going to be ugly. Pretty ugly, but you get the idea. And then the mirrored one is down here. And we're done.